Hi everybody, I'm Alireza. I will perform a comprehensive quality control and quality assurance on a Fullsuite CDR package acquired through wireline logging in one of the southwest Iranian oil fields. We will working with a robust set of logs including HDIL as the resistivity log and CDR as the deviation survey log and DAL as the sonic recording log, ZDL, CNL, and DSL as the nuclear run. At first, we should detect the casing shoe to validate the depths with the result of driller casing shoe detected by the drillers. The driller proposed 1840 the driller proposed 1889 as the driller proposed this step. The driller proposed 1889 here as the casing shoe depths. However, as a result of let's check the shoe depths and validate by our logging Fullsuite logging package. For this, the most reliable way is to check the ZDL log here. Then the caliper in the nuclear run will be closed here. We can say that the log, the tools are entered to the casing and pass the casing shoe. By a standard procedure, 1 meter below which the caliper is closed can be selected as the shoe depths by the logger. Here, as proposed by the logger, a 1486.5 as proposed as the CSG logger. Okay, there are 2.5 meter difference between the logger and driller's shoe depths difference. Okay, in the next step, we should check the response of the logging tools in the Caprock. As can be seen in the Caprock, which is mainly composed of anhydride, resistivity shows very high readings in about more than about 200 or more ohm meter. um, SGR and CGR will touch each others, in which SGR will shows or gamma ray will shows a mini a minima a minimized point equal to 10 GAPI or less. DT reading shows 52 or 53 microsecond per feet. TEF readings are more than 5, and neutron shows -1 or -2 porosity unit reading. In addition, density density readings will be equal to 3 gram per cc. Let's check the in this log. As can be seen, we have several intervals in which the resistivity curves are more than 200 ohmmeter. Moreover, SGR will show a valley in several intervals. In addition, by a comparison, with HDIL with um, ZDL CNL log in the same intervals, we see that in some intervals density log will be more than 2.95, or even they will equal to 3 or more. In these intervals, density will be more than 3 gram per cc. In addition, F readings are very high, more than 5. Let's check the sonic log. Let's check the sonic log. How can we shift to the sonic DAL to check the readings? By checking the readings of sonic or DAL tools, we can see that in several intervals, low values of DT readings can be obtained. Here about 52 or 53 readings, or here as a result, we can conclude that the shown intervals can be good candidates for anhydride in this well. But we should propose that the results of the readings of several logs are affected by the borehole or the borehole washout, borehole conditions, mm, and the casing. Therefore, we cannot certainly mm, give a certain result in this row. After validation, shoe depth validation with drillers, data, and Caprock detection, we are gonna to evaluate the readings of several logs solely and simultaneously with other logs. For example, let's check the readings of the resistivity log in this well. Let's scroll down. As can be seen, in this well, we use an OBM-based drilling fluid. As the invasion of the drilling fluid mud into the X zone or flush zone, we expect higher readings in the higher resistivity readings in the near borehole regions. As a result, M2R1, M2R1, which has the lowest uh, depths of investigation, the black curve, has the highest, shows the highest readings in this well in most intervals. But there are some exceptions in some interval. It may be due to several conditions. And M2RX shows the least readings. The red curve shows M2R1 and the black curve shows M2RX, which has the highest depths of investigation, about 120 inch into the formation. The peaks of all resistivity curves are depth matched. There are reasonable separation between the all resistivity curves. The trends of all curves are compatible to each other from from the top log to the bottom hole. These conditions are valid. The high separation between the low depths of DOI curve resistivity with high DOI resistivity curve shows high permeability of the layer. In this zone, we have high permeability. The same as above, high separations can be seen here. When the separation is very low and all curves are matched to each other, on each other, it can be an indication of low permeability of the layer. After HDIL curve, we should check the DAL as sonic recording log from top hole casing shoe to the TD. We scroll down. We have 4 TT curves or transit times in microsecond. They range from 100 to 20 or more microseconds by taking an average from these curves per feet. The DT curve, the delta T curve can be obtained. As can be seen, all curves are smooth, no anomalies can be observed, and the readings are reasonable. The readings of all curves are depth matched, are compatible with each other, and no spikes rare sparks can be shown. After checking sonic curve, we should evaluate the trends and readings of nuclear logs. Let's check ZDL, CNL, DSL logs through the whole interval. In order to evaluate the density log, we should check the variations of d rho, z core, or d rho as a QC for density. As can be seen, in this interval, d rho reads about 0, reads about, reads about 0, so the readings 0, 0, so the readings of RHOB are valid. Here, RHOB reads valid readings. Both RHOB and NPHI should have compatible trends with each other. In these areas, RHOB is placed in the right-hand side of neutron log NPHI. So these intervals are dolomitic layers. Here we have some in these layers, RHOB shifts to the left-hand side of neutron, which can be a sign of um, uh, sandy layers. Here, sandy layers may be sandy layers, but neutron is affected because high readings of D rho is observed here. We have some washouts. As can be seen, caliper reads very high values with respect to the bit size. When PEF reads about 5, 1, 2, 3, 4, 5, it can be a sign of limestone reservoir. Both NPHI and RHOB aligns on each other. These intervals are limestone, are composed of limey reservoirs. This separation between RHOB and neutron are due to the presence of some amount of clay. Good match is can be seen in this layer because of very low amount of clay. This is a limestone reservoir composed of very high porosity, which shows high porosity 2115. Let's check the resistivity log. Resistivity log at 2150. This is a limey reservoir. A limestone reservoir, PEF is equal to 5. The reading of CGR is less than 10, about 5 GAPI, and RT value through formation resistivity is about 110 20. Okay, uh, the trends of RHOB and RT are similar to each other. RHOB and neutron goes to the left and resistivity also shifts to the left. Let's check the readings of sonic at these steps. 21, 15, 21, 15, 21, 15, and this interval mm, sonic reading is equal to 50 microsecond per feet or more. Which is acceptable. Let's check these peaks. Let's check these peaks of resistivity. These peak, these, and these peaks at depths 20, 20, 2200, 2200, 2200. The variations of the sonic log is has less variation range, small variation range, so we can see this peak from resistivity which is equivalent with this peak, this which is equivalent to this peak, this which is equivalent to this peak, this tiny peak with this peak of sonic log. Let's check the ZDL log. ZDL 2200, 2200. As can be seen, this gamma ray peak is not matched with the gamma ray peak in the nuclear log. About 1 meter or 1.2 meter, the nuclear logs should be deepened. It is shallow. The nuclear log is shallower than resistivity log, and it should be 1.2 or 1.3 mdd should be deepened to be depth matched with sonic and resistivity set. See this peak? This peak is about 1.3 mdd deeper than nuclear spectral gamma ray of nuclear set. Anyway, we can, after depth shifting of the nuclear log with the resistivity set, we can check the peaks of both sets with each other. As can be seen, this peak of resistivity, for example, this valley of resistivity is in correspondence with this peak. Let's check this peak at 2275, 2275. This valley of gamma ray can be seen at a spectral gamma ray of nuclear set. We have about 1 meter or 0.2 MDD difference between two sets. This peak is in correspondence with this peak, and this with this peak. These two peaks are also in correspondence with this interval. This valley is in correspondence with this valley in this peak of neutron. The same analysis for peak-to-peak evaluations can be done as shown. Therefore, there's a good match between the readings of resistivity, sonic, and nuclear logs, including ZDL and CNL readings. Trends are compatible with each other. What about the values? Let's check the values. As can be seen, in these intervals are totally limestone, composed of limestone, and we expect PEF equal to 5. And PEF reads less than expected values in some intervals, less than expected values, less than expected values. Because of the we use mud-based, oil-based mud in a limey reservoir due to the reasonable porosity, about 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, about 9%. We expect the density shift to be shifted to the left hand side of the neutral. It means that a sandy behavior should be seen in the nuclear set. As can be seen, PEF is less than expected value. In these intervals, PEF should read 5. In the in 1500 MDD depths, the, the values of PEF also are less than the expected values, which is about 3.1 or 3, which is very, very low and should be near to 4. This is a the, this is a carbonate layer made of dolomite based on the separation between the neutron and bulk density. So PF should be more than 3 and near between 3 and 4. So PEF reading is not acceptable and the curve should be normalized. Less than PEF values are less than expected values. Less than expected values. Dolomite composed reservoir layers composed of dolomite. This is a sandy layer, maybe sandy layer. In sandy layers, no, these readings are wrong. These readings are wrong. Readings are wrong. And we have no sand in this well based on the near biwell data. Okay, it was a this video was a short description and quality analysis and quality check of a Fullsuite package log in one of the Iranian oil fields. Thanks for listening to this episode. Bye.